So in the last video, we left off with a 5-gram puddle of water with the current temperature of 0 degrees Celsius. And I highly recommend you watch the previous video. I have a link of it below because we're going to build upon those ideas. But now we have a 5-gram puddle of water with the current temperature of 0 degrees Celsius. Now what's going to happen if we add more heat to this puddle of water? Well, clearly if we add heat to this puddle of water, the temperature is going to increase. For example, let's say we add heat to this puddle of water, and let's say the temperature increases from 0 degrees Celsius to perhaps 25 degrees Celsius. Which makes sense. So let's say we add this amount of extra heat, and once we add that amount of heat, we saw that this amount of heat, we saw the temperature increase from 0 degrees Celsius to 25 degrees Celsius, an increase in temperature. Now what's going to happen if we add more heat? Well, again, if we add more heat, the temperature is going to increase even more. So maybe we add more heat, and now the temperature increases from 25 degrees Celsius to 50 degrees Celsius. So again, now we add this extra amount of heat, and when we add this extra amount of heat, we saw the temperature increase from 25 degrees Celsius to 50 degrees Celsius. And again, what's going to happen if we keep on adding heat? We're going to keep on increasing the temperature. So now let's say we add a lot of extra heat, and once we add a lot of extra heat, the temperature increases from 50 degrees Celsius to maybe now 100 degrees Celsius. So we add this extra amount of heat, and we saw the temperature increase from 50 degrees Celsius all the way up to 100 degrees Celsius. But you might wonder, exactly how much heat was required to increase the temperature of this puddle of water, this 5-gram puddle of water, from 0 degrees Celsius all the way up to 100 degrees Celsius? Well, to determine that, we need to use our specific heat capacity formula, and we know the way this formula works. If we know the mass of an object, and we know the specific heat capacity of that object, and we know the observed change in temperature, we can determine how much heat was required to cause that observed change in temperature. And in reality, liquid water has a different specific heat capacity. I'm using this value for simplicity, for the numbers for simplicity. But again, so now we can use this formula to determine how much heat was required to cause that change in temperature. And again, we just plug in all the values we know. We have a 5-gram puddle of water with this particular specific heat capacity, and we saw a change in temperature of 100 degrees Celsius. We went from 0 degrees Celsius to 100 degrees Celsius. So under those conditions, how much heat was required to cause that change in temperature under those conditions? Well, again, now we just use some math and we solve for the heat, and we see the grams will cancel and the Celsius would cancel, and that will give us joules, the amount of heat. And now we would just multiply them and we would get 4,000 joules. So now we know how much heat was required to cause that change in temperature. It required 4,000 joules of heat to increase that temperature of this 5-gram puddle of water from 0 degrees Celsius all the way to 100 degrees Celsius. So now what's going to happen if we add more heat? Well, it's important to realize is the boiling point, the vaporization point of water is 100 degrees Celsius. So now what's going to happen if we add more heat? Well, now that heat is going to be used to vaporize this puddle of water. So if you're interested, I have a link below on what's going to happen if we add more heat to this puddle of water. I have a link below on that video and what's going to happen.